music exists in a world where people can hear the vibrations, and in the subatomic world we cannot hear the vibrations. So it's difficult to say that there is quantum music. However, what can be done, we can build transducers that translate, the vibrations from one world into another. Then we can, let's say, eavesdrop the subatomic world. So in my work, I prefer to say quantum computer music, because I'm interested in harnessing the computational power of quantum mechanics to process data for me, to generate data, to generate music, and data that I can transform into music and compose with. Of course, quantum computers are in the very early stage of development, but still, the way I want to use them can already do the same job as powerful AI algorithms are doing at the moment. So with only 5 qubits, I can develop algorithms that can already compose, interact with musicians.
What you see on my right here is the spinal cord and the nervous system of the Starman 5 backend, the superconducting backend of Kwantumwerk. I am Vivek Sinha. I am a technical project manager at QTech. I work closely with Professor Leo Di Carlo on superconducting quantum computers, which is one of the many quantum computing technologies that we work on at QTech. And it's one of the backends in the Kwantumwerk platform. Kwantumwerk is a cloud-connected, publicly available, and free quantum computing platform. It's one of the demonstrators of QTech. It's also actively used for education purposes, for example, in quantum computing courses at TU Delft. And it's important to mention that it's also a test and development platform, not just at the national scale, but also at the European scale for quantum technologies.
I'm Ruggero Di Carlo, a PhD candidate in the Di Carlo lab, and I'm the one who's taking care of Starman 5. Actually, I make sure that it's online and well calibrated. As a research project, I detect cosmic rays using Starman 5 in Kwantumwerk. This project that we did with Eduardo Miranda was the first art project that we did with Kwantumwerk. Until now, we have done only more physics-related projects, but it was nice to have this new challenge and try this more creative type of projects.
You see that musicians are already playing with the machine. My laptop listens to what they play, then it builds the algorithms representing the rules of the music that the machine listens to. Then it sends to the quantum machine, receives information back that can be converted into music. And this information is actually responses to the music that it heard.
Okay, one of the biggest challenges of this project was actually the fact that it was live. So when you send a job to Kwantumwerk, of course, you have to wait some time before you get back the data. But Kwantumwerk is equipped with mid-circuit measurements that allowed Eduardo Miranda to send more circuit within one job and get all the data at the same time from Kwantumwerk.
I have this kind of dream that I wanted to realize, which is, imagine that you have a piece of music, right? But instead of writing it, in a music score or storing information somehow, what I've got is a powerful quantum algorithm that builds this music in a kind of Hilbert space. And then every time I look at this space, every time I hear, I get a different version of it. So I imagine that with more qubits, I would be able to represent the rules of a symphony like this. I think it's important that musicians and artists start thinking about how the future of our art may be shaped by this technology. Right now, we can begin doing these things right now.